Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. So, prep. We need to prep for our book.
Yeah.
Trying out the new acronym.
Okay. And so what's the new acronym?
What is it? Performant.
Yes.
Reliable.
Uh-huh.
Expressive.
Yes.
And productive.
Yeah.
That's what our book is going to be about.
I think so. Yeah, I think that works. And it's an acronym, so people can then start referring to it as if it were not just a made up thing.
Yeah.
Go, oh yeah, we follow the prep
methodology
or whatever. Yes. And we need to figure out expensive certification for it.
Yes.
That will be
prep certified.
That'll be our business model. his certification, because historically, yeah.
Got to have the badge.
Yes.
I've been reading the Dr. Seuss Stars Upon Thars book a lot with the kids, and there's a lot of culture that revolves around stars, having stars.
It's true.
Yeah. And then the people who create the was his name? The guy that created the machine, to the star on and star off machine, and makes all the money just putting stars on with the stars, the people who don't have stars, the Sneetches who don't have stars. And then of course the ones with stars are really offended. And so then he has them pay to get the star off machine so they can still be special. And then it just becomes this infinite loop of star on, star off. But I'm like, man, this is visionary on
exactly. Because isn't this how the Scrum stuff works?
It's how everything works.
Scrum Master. Well, yeah. When Java initially came out, they had their various levels of Java certification, which you there were people who were convinced that they needed Java certification.
Yeah. Oh, and here's what's wild: his son also at that time had a methodology that you could get certified in that was called the STAR methodology.
Oh my gosh. Named after Dr. Seuss.
Yeah, Sneetches.
Yeah. Sneetches. Well, that's true. We could
just pay your money and get your star on.
Yeah, that's right. Okay.
The only thing that doesn't quite work is that no one ever pays to get the star off. We just pay for more stars.
We pay for more stars. And is there some way we could mix the NFT craze into this?
Oh yeah, definitely. If we could figure out how to do NFTs, yeah. We
could just draw each star by hand and then take a picture of it.
Yeah, actually. So we were actually it was kind of joking around, but kind of not. I have this microservice battle thing that I've been doing for customers and stuff, where it's just a fun way to learn some technology, and you work on your algorithm, and you have these microservices that fight against each other. And because we originally started doing these in person, we did one at Winter Tech Forum last year, and it's fun. And in person, you can do physical rewards for the winners and all that. And at conferences, we were doing giveaways, and that worked well. But now that we are all virtual for these microservice battles, it's been hard to do the physical giveaways for the winners. And so at some point we're like, what if we gave away NFTs as the prizes? It's like the new conference swag for these virtual conferences could be NFTs. And yeah.
And you don't have to stuff bags that way.
That's right.
It's very ecological. You wouldn't even have bags.
That's right. Well, you could have an NFT of a bag.
And a t-shirt.
Yeah. And here's your NFT of a t-shirt.
Yeah. I don't know. It's
silly.
Is it just a new kind of currency, maybe?
It's a new star you can wear. You can go through the star on machine and get your star, and that makes you feel good.
Yes. Well, I'm all about feeling good.
Yeah. And I guess maybe the promise is that if you did want to resell your star to someone else, you could do that. Where in the Sneetches, they got their stars on, but they couldn't transfer them.
They were tattooed or something.
This is ingenious.
Mm-hmm.
The stars for Sneetches, but that you can have a marketplace around.
We're looking for venture capital on this idea.
Yeah.
This is where we go independent.
Yeah. So back to prep and
yes. Yeah. What's the origin of this? This is just some crazy idea that came into your head, and you go, it's got to have an acronym. And
Well, because we started the book
Mhm.
around like why is Scala 3 and Zio awesome? We're like, oh, easier reliability. And then we were like, well, yeah, reliability and performance. Like, yep, okay. We got the R and the P. But then I was like, productivity is really part of this triangle because, yeah, you can have reliability and send something to Mars, and that's great. But hopefully we can make that a productive experience as well.
Mhm.
And I think that that's one of the things that Scala 3 and Zio really shine on is the productivity and balanced with productivity balanced with reliability and performance. And so we've got the R and the P and the P. And I was like, we need a good acronym because everything has to have a good acronym.
Well, you need a vowel.
We need a vowel. Yeah.
Yeah.
And so, so then I was like, well, PRP, if we threw like a vowel after the R, and I went through all the vowels and I was like, E, prep. But what does the E mean? And so I was trying to think of good things that kind of related with an E. And so I was like, I don't know, expressive, but that's just, I don't know. There may be a better E, or maybe we don't need an E because this is all just manufactured silliness anyways.
Yeah, but it'd look better on the badge.
Yeah, I mean, we could print stars with PREP, and that's, definitely looks better than PRP. Because PRP kind of sounds like a drug or something.
It does. It sounds like PCP.
Yeah.
Or it could be PROP, like, well, we could throw objects in there.
Ooh. Or ROP.
Or ROP, yes. Well, and it's interesting because this article that you...
RUP.
Oh, wait. No, it's been taken. Yeah. And does rational even exist anymore? It's just a subset of IBM, right? The RUP is the Rational Unified Process, which is way back. I don't know if anybody actually still uses it, but
there was some interesting articles on Hacker News this week about UML, and so I was thinking about, like, I'd forgotten about UML for like a decade, and then all of a sudden I was like, whoa. We used to do UML. Does anybody still do UML?
Did we though?
Or I've got the sequence diagrams to prove it.
Yeah, it's funny because it seems like most people talk about things like sequence diagrams, but not what started UML, which was how do we describe objects?
Yeah.
And so...
Yeah, relationships.
And there were... Yeah, I think this is worth going over. I mean, to me, it doesn't seem like such ancient history, but there were like pitched battles at conferences about whether your objects should be represented by clouds or by boxes.
Diamonds or serious.
Yeah, no, it was like people would fight over this, and you had the people who eventually got combined into the Rational Unified Process. They were fighting against each other about.
Was the ruppers versus the sluppers?
It was basically boxes versus clouds, and this was really important because this was going to establish the future of how we, draw forever.
And then it turned out no one used
it anyway. It was they were solving a problem that didn't need to be solved, and there were just like,
how many times does this happen in our industry?
This was the first time.
Battles.
It never happened.
Battles over things that end up not mattering.
And then in the 90s, we had the AI revolution. Believe it or not, AI was invented way earlier than now. It's just that it didn't work then.
Yeah.
And it became a complete marketing thing. It was all, people were getting excited about it. I'm going, I'm not sure what you're selling. I have not actually, this is why I'm very suspicious of the low code, no code stuff.
Yeah.
Is because it was like, until I get my hands on it and see how it works, it sounds like a marketing ploy, and that happens. It's like the Ponzi schemes that regularly go through various populations.
Yeah.
And, time will pass, it'll settle down, and then somebody get all excited. Oh, you can make a lot of money if you get your neighbors to buy products and stick them in their garages, and then it's like, no, this is a Ponzi scheme. They don't know what it is.
Yeah,
because enough time has passed.
It's no wonder that developers are so like just any kind of marketing they have such a good radar for, and they're so hesitant to trust anything that comes in a marketing
most of the
way.
time it's just
lies.
Yeah, lies. That's the word I was looking for. It is just lies, because their incentive is not to come up with really good technology. It's to make a lot of money fast.
Yep.
And that's, so, and it's not even, I mean, technically marketing is finding out what the customer wants. So what we're really talking about is sales here. We're just talking about.
Yeah. Well, I think marketing has been construed into lead generation.
Mm-hmm. Mm-hmm.
It's all that it matters is get us some leads.
Steak knives or the Cadillac.
Yeah. Yeah. So anyways, I'm excited about prep because I'm going to do some marketing here because it's going to be amazing. Going to change how people build software.
It's going to solve all of your problems.
All of them. Every single one.
That's right.
It is the first silver bullet in technology.
Mm-hmm. The first honest silver bullet.
That's right. Yeah. No, it's going to be fun. We're having fun. We just had a book working sesh last week or on Tuesday, and Bill and Bruce and I, and we were exploring the difference between functions and monads and grappling with okay, what is unique about monads? Because functions compose, monads compose. What makes monads different and unique? And we're still kind of wrestling with explaining that in a value-oriented way.
Well, and also we're struggling with whether mathematical function composition, where you say f of g of h, where they're all inside of parentheses, versus function chaining. So you'd say, call f, it produces a result, you pass it to g. Well, or actually, if we were to do it in the way we describe it, you call h first.
Yeah.
H passes its result to g, which passes its result to f, and you get the result coming out. It's like, boy, those sure seem pretty similar. Is there any fundamental difference, or are we, is function composition the same whether you're chaining or quote unquote mathematically composing?
Yeah.
I mean, I suppose, well, even if you think of it in terms of, consider the result another function, which is what you do mathematically, you'd say.
Oh, that's true. If you do h, then g, then f, the result is not a value. It's a function that takes the input of h. And
if you're doing it that way. But if you chain them together, you can assign the result to a function that takes the input, runs it through the chain, and produces the output. So is it really, that different?
Yeah.
And in both cases, I think if you're, I'm still learning about.
One of the interesting things along these lines, this is a bit of a tangent, but one of the places where I use that function composition where I don't do it as f, then g, then h. Instead, I actually create a new function. So one of the reasons why I do this is because I do it with taking specific parameters out of that kind of chain and pulling them out to the function that I'm creating. And so then I can kind of pick where I put the holes, like which holes I expose in my outer function. And so that's one of the places where I use this. I think that's part of currying or related to currying, because you can create new functions by taking parameters kind of and pulling them out.
Mm-hmm. Right.
So that's one of the useful places where I've used the function, then function.
And I guess my question is, when thinking about monads, is there a difference between, let's say, mathematical function composition and chaining? And maybe there is, maybe there isn't. I don't know. I'm still I'm still getting like just what you told me this morning, where you said, because I had been imagining, regardless, that you have a function, it produces a monad, that monad is passed to another function, which does something to it. And so it's passing the monads down. And you're telling me, oh, no, that's not how it works.
Yeah. Yeah. You have a monad, and when you chain that monad to another monad, what you're doing is you're in the flat map of the monad, you're returning another monad. And that's how it's different, I think, than function chaining. So what that means is that, like, once you're in monads, you stay in monads. You can't leave the world of monads, at least in a nice way. You can transform from one monadic type to another monadic type. But
and at some point you're going to want to get the value that the monad is holding.
Well, you do that. You do that with flat map, or whatever you want to call your monad functor, the function that takes the value and returns a new monad.
Isn't that always flat map?
Other languages have different names.
Okay.
In Scala, it's flat map.
Okay. Well, yeah. I wonder if drawing a diagram might be, and I know I've seen people try and draw diagrams that just confuse me.
Yeah.
But I bet
there's the category theory diagrams.
that would confuse me. And I've seen the what is it, the parallel track or railroad or something diagram.
Yeah.
Also confuses me. But I'll bet if we worked on it, we could figure out a diagram where it started to make sense.
Yeah.
Yeah.
Yeah. Well, I'll keep exploring, and this will be good content in our book once we figure out a way to explain it.
Fortunately, I maintain beginner's mind about all of this. So I keep asking the very basic questions, slowly fitting pieces in.
Yeah. Yeah. We'll figure it out.
Yes, we will solve
and then we'll get our prep badge.
Yes. Right. Should I have the designer start working on that? The prep badge?
Can you give it to us as an NFT?
Probably. But then doesn't that mean there's only one?
Well, but can't you create NFTs that are replications of NFTs? It's just NFTs all the way down. It's like monads.
Yes. So I don't know. I don't know. So I decided I was going to give a presentation at the Craft conference, which is in Budapest. And several years ago, they brought me over to speak, and it was very nice. And so I did want to give this presentation, but it's just been fighting me the whole way. And
what was the presentation going to be?
So the presentation was going to be called Java and the Death of 1,000 Cuts. And it was going to be pointing out how all of these features that have been added to Java for the last, I don't know when you would consider it starting, probably Java 8, certainly lambdas, for example, because, lambdas are cool, but then they have their weird limitations. There's things you can't do with lambdas that you would have expected to be able to do it if you had come from other languages. And suddenly you've got these hacks that you have to do in order to make your code work. And when you look at it, it doesn't make any sense. Why did you take this particular item and have to externalize it from the Lambda, for example? And then you have to go, oh yeah, I remember, because Java is limited in this way in their implementation of lambdas. And there are things like, a very simple example is override. The override annotation, there's no real enforcement for that.
Right.
So, and the upcoming record, the last I checked, it didn't have a copy function, which seems pretty essential. So there are all these things where it's like, it's sort of there.
Yeah.
But then it's missing a feature which makes it kind of weird and awkward to use.
Yeah.
If you're, aware of what that feature is. And so my argument was going to be, well, and look, Kotlin does all these things but in a regular expected way without the funky things that they had to do in Java to fit the feature in. And so my thesis was going to be, so you should just continue using the Java features you have. And if you really want to move forward and use fancier new features, you should change to Kotlin. Sounded really good in my head.
Yeah.
And I think it was Bill pointed out, he goes, yeah, I've worked at places where people were really excited about those features and, improved their lives, and they didn't have to change languages because it was too hard politically, et cetera, et cetera. So I started thinking about that and going, what does it help to rain on somebody's parade like this? It's like, you're excited about these new features, and I go, it's actually not that great.
Wrong.
Wrong. You should use Kotlin. It's like, I don't know. I'm kind of over. I've been pointing out the issues in Java. The thinking in Java is filled with explanations about why something doesn't work the way you expect and how to get around it. And I was like, I'm just kind of tired of all that.
Yeah.
So I just didn't have my heart in it.
Yeah.
And I couldn't think of any. I mean, the only other thing that I've really been kind of working on for a while is dealing with failure, and just looking at the history of that and all the different things that we've done. I did a presentation, I don't know how long ago, probably 8 years ago at PyCon, where I was talking about it, but it was sort of incomplete. And I realized there's much more about failure and dealing with failure and all the different approaches that we've taken. But that's still formative. Until I have a really good understanding of monads, I think I'm not going to have a full grasp of the failure picture. So I couldn't think of anything. So I wrote an apologetic message to the conference organizer and said, I can't do this. And it was helpful.
Yeah.
It was liberating. Yeah. So, and I think when I do my final, which I imagine would be the next one after the On Java 8 book, my final coverage of Java, I'm just going to talk about how to use the features. I'm not going to talk about the broken stuff and the stuff that, where they made.
Show them the happy path, and
don't
show them the thorny, long, painful way that they could alternatively go.
Yeah. And they'll encounter that when they're maintaining the reams of existing Java code that's out there. They'll have to understand that, but I don't know. I would rather just say, yes, we use type inference everywhere, for example. Yeah. And yes, we use records, and maybe you have to write your own copy function, but that's how it works in Java.
Just stay on the happy path.
Yeah, kind of. I don't know if I should, it should, I don't know if happy path Java is promising too much, but anyway, that's what's in my head right now. Who knows what'll actually happen.
Yeah.
I have also asked myself whether just continuing to write books am I just doing it because that's the easy way to go? And maybe I could be doing something that's way more fulfilling.
Yeah.
And I don't know the answer to that.
Yeah.
Besides, we're working on this book, and it's been quite pleasant so far.
It's been fun.
Yeah, definitely.
This reminded me about, I just heard in a meeting yesterday, someone was saying that I would be shocked by the number of Java projects that use Lombok.
Really?
That the actual usage numbers of Lombok are astronomical. That anybody that's really using Java, they've likely adopted Lombok to work around some of the paper cuts that you get in Java. And I thought that was interesting. I've heard others say you could switch to Kotlin, or you could just use Java with Lombok. And I haven't personally used Lombok because I think around the time that Lombok was becoming a thing, I was in Scala, so I didn't need Lombok. But thought that was interesting to think about. Okay, people have felt the cuts, and they have figured out ways to deal with those, whether Lombok or Kotlin. Or Scala.
But when you say surprised, I don't know if that means 10% of all the industrial Java projects out there are using
the hint was that it was a large percentage.
Okay. Mm.
So I don't know. It'd be interesting to get real usage numbers, but I mean, you could totally see it if you have a large Java code base.
Mm-hmm.
Sure, you could generate your getters and setters, or you could just use Lombok.
Mm-hmm. Well, and it'll generate data classes for you too, right?
Yeah.
Yeah. I mean, that's got to be a fundamental thing.
Yeah.
Yeah, and I'm not sure how far it goes, but yeah. So
seems like Lombok is the Kevlar to, if you're in Java, it's the Kevlar to shield you from those paper cuts. Like it's maybe the easy way to do that.
Or is it even the original test bed for features that eventually go into Java? Because I mean, records
could definitely,
for example,
be a lot of inspiration for.
Yeah.
Figure that if it's getting usage in Lombok, then maybe it should just be part of the Java.
Yeah. Yeah. But
it's, I wonder if their goal is to not be needed. There's some projects where the stated goal is to no longer exist.
Mm-hmm.
That's my WebJars project, which is now on 7 years or something like that. Mm. The goal of WebJars is to not be needed and to cease existing at some point. And it, yeah, unfortunately,
that is a laudable goal.
Yeah.
Yes.
There are some things that have made that goal, I think, move further along. JHipster makes it so you don't need WebJars. And Kotlin, in Kotlin, the you can do Kotlin JS and write JavaScript stuff. So they've got this NPM integration that I just used for the first time recently, where it'll pull NPM modules in for you, and so again, you don't need WebJars, which is great. Like all those web libraries, you should be able to just pull from NPM and not have to use WebJars. But so I wonder if Lombok's like goal is to not be needed, or maybe their goal is more keep pushing and have parts of it that become standard in the language, and so parts of it are no longer needed. But they keep,
because anything that makes Java programming easier it benefits a huge number of programmers and companies. Makes people more, what's that P word? Productive.
Yeah.
Well, and you could argue for expressive as well.
Yep.
Yeah,
for sure.
Yeah. So, I mean, something like that. And I think I would rather, because I've always written as if Java is all you have. And I think that's a mindset left over from when I was working in C and C++. And the idea of a whole bunch of tool sets was not there. And now really there is fundamental tooling that no sane person would want to work without.
Yep, that's true.
So, that might be one of them. And there could be other things like, I don't know, some basic database stuff that rather than using JDBC.
Someday. The only innovation really in that space is the reactive JDBC drivers, which are all the rage right now, which is good. It's good to have reactive database drivers. Like that's just, of course. Yeah. But the actual databases still, at least relational databases, still run SQL. And so at some point you have to get to SQL. You can make SQL easier to write. You can abstract it so that you don't write the SQL generally, like Hibernate. But yeah, I haven't seen anything like, actually I have. Cloud State. Cloud State is a revolution. I would say a revolutionary model around data storage and distributed data and queries on that data.
And
Cloud
who makes that?
Lightbend, the
really?
company behind Akka and Scala and all that. So, they're doing some really interesting stuff with that.
So, is that Scala only?
No, one of the coolest things they've done is they have made the interface to it protobuf based, and so they have a number of client libraries because all you have to do is generate the stubs from the protos.
Mm-hmm.
And so I've used it in Kotlin, Java, JavaScript. I think they have a Node or a Go version. So it's very easy for them to support other languages.
And what's the model that you're imagining while you're manipulating this database? It's
very different.
It's not like an object relational mapping.
No.
It's not an object-oriented idea. It's like, what does it look like?
So in Cloud State, it really is making CQRS easier. So CQRS is command query response segregation.
Okay.
And CQRS is it also makes event sourcing easier, but I don't know a whole lot about event sourcing. I've mostly used CQRS. So I'll talk mostly about that. So in CQRS and event sourcing, your source of truth is not your mutable database. Your source of truth is your event log. And
right.
it's a flip of the model from a traditional
kind of like the
database.
way Elm works.
Yeah. Is you've got all these events, and you can get to the truth by replaying all the events.
Right.
And the way that in these systems, you need some way to like query, okay, what is my current state? Mm-hmm. And so this is where the command query response segregation comes in, is your commands are your events that are happening. And then what you do is you have a listener on that stream of logs that is doing filters, doing, whatever you need to do to then get to the queried state that you then need to use in some other place. And so Cloud State makes this programming model easier for doing this. So you have a method, a function that is receiving the events, and you set up your queries, and in that function, or you can have multiple listener methods that are listening to the log, and then Cloud State is maintaining a bunch of things underneath the covers for you. So one of the challenges with CQRS is that if for some reason an instance dies and you need to get back to your state, it can be really costly to go replay all the events in all of history to get back to your current state. So CQRS systems typically will do snapshots. Mm-hmm. So you can say, all right, based on this point of time in the log, here's where I'm at, and start with that snapshot and then play forward from there.
Sure.
And so Cloud State just does that stuff for you to make it perform well. And
you decide how often you want your snapshots.
It is configurable.
Oh, okay.
And like the backing store for where those get stored is configurable.
Yeah, that makes sense, because totally the event is the smallest unit of change, and not what we've typically translated it into, which is what change do I tell the database to make? But instead, this inflow of events is more atomic.
Yeah. Well, and on the distributed side of this, if you have a stateful mutable database, dealing with distribution of that database across more than one machine gets really hard. Really hard to do that right. And so one approach is what Google Cloud does with Spanner and atomic clocks, to make sure that every machine knows exactly what time it is, and so that then you can have atomic, incrementing whatever numbers to get to your consistency. And so
did they take into account the speed of light?
I'm sure. Well, so there is a window. So whenever you have a distributed database, you have some like window of reconciliation. Okay. And so Google also has the super fast network around the world that runs these like synchronization events on, so that they happen as fast as they possibly can. But then you still have to have this window of time that if you did the write way over here in Australia, and you're doing a read in the United States, there's some amount of time that those are going to be out of sync, have to be, because of the speed of light and the speed of computing. Yeah. And so distributing a mutable stateful database has a lot of challenges. Whereas in the event stream based world, it actually becomes a lot easier to have guarantees around when things are in sync and because you're not, all you have to do is wait for the, as soon as the event arrives to an instance, your state is updated. So it's a much easier model to think about how that happens. And then there's something else called CRDTs that I don't really understand that are a core part of how you do ordering of distributed events and stuff. But Kafka is really one of the central technologies to this event logging kind of system. And I'm not an expert on any of this, but I've dabbled and I think that there is something that is pretty revolutionarily different about this approach than the typical SQL query model. But anyways, that was an interesting tangent.
Yeah. Tangent from what though?
Oh yeah. Tangent from JDBC is where we started.
What's on our list?
We were going to talk about reliability,
yes,
in terms of process, because our prep book is going to talk about reliability in the programming model, how we get better reliability from the programming model. But we are going to, at the book, say we know that there are different ways to accomplish reliability. We're going to focus on the programming model side of that, which I think has been the most neglected side of reliability. But there's been a lot of work on getting better reliability through process. And so we were thinking maybe today we should talk a little bit about how process has made us more reliable over the years.
Right. Yeah. So I remember, I think this was Barry who introduced the idea that you couldn't do refactoring until you had automated builds, testing, and let's see, what was the other one? Oh, version control.
Yeah.
Version control. And so those are like the three fundamental things, but then I would add versioning. I would add to say, yeah, you actually, not only do you have to have version control, but you actually have to have a reliable versioning system so that you don't end up, using the wrong piece of software.
Yes.
And then with those things, your software can evolve. And I think refactor is a specific version of evolving, because refactoring is like, you're not changing the behavior of the code, but you're making it more maintainable.
Right.
And I think just in general, what we want to do is have a system where you can, you can move forward, you can add features, you can refactor, you can do whatever, and your system remains reliable.
Yeah.
And there might be other factors that feed into reliability. Maybe some of the stuff that the Agile folks have brought up, just in terms of how you communicate about how your system is going to evolve, because that's mostly the focus with Agile.
At some point, the vernacular for like regression test became a thing, and we started writing tests to prevent regressions.
I never made that connection. We call it regression testing. And I was going, what are you regressing to? And you're saying, no, it's to prevent regression.
Yeah.
Oh, man.
Yeah.
That's just clicked for me. All right.
Yeah. So when I have a bug in something I've built, not always, but often, what I will do is write a test that fails in the current state of the machine. Yeah. And then I fix the bug, and now the test passes. And that now is a regression test, because if I ever accidentally reintroduce that same bug, that test is going to fail.
It should be called anti-regression testing.
Yeah. Yeah.
Okay.
So oftentimes in I would say mature development organizations, if you are fixing a bug, there better be a test that comes along with it. as a tangent to this, I'm disappointed that the industry has not yet had a good way for somebody who's working on a bug fix to first submit the test and show, okay, this test shows that we have a bug because it is failing, and then update or whatever to show, all right, I now have submitted the bug fix and now the test is passing.
It's really the scientific concept of falsifiability.
Right, exactly. And I've not seen people really do this. What usually happens is at the same time you submit the bug fix and the test, which doesn't give you the falsifiability. It doesn't show you that, oh, the test proves that you actually fixed this bug. As in the development process, hopefully the developer actually started with the test,
made sure it
failed, and then fixed the bug and showed that it passed.
Right,
but that's not expressed in the tracking in what they actually then contribute up. I suppose you could do like a git bisect or
you should
something.
Check the bug in first. I mean, the test in
first to then show that it fails.
But then you're checking in a system that fails when you run the tests.
Yeah.
So we're not supposed to do that.
We're not supposed to do that.
I see.
Well, if you're doing it on a branch that is your own branch. Then...
But see, what you want is for anybody to come along and go, okay, I'll check out the version with the test that demonstrates that this fails.
Yeah.
And then I'll check out the next version, which shows that it succeeds.
Yeah.
Yeah. So there's not repeatability, basically.
So I think you could do this with a git bisect.
Mm-hmm.
If you have a commit, it would require that you have a commit that has the test and a commit that has the fix as separate things.
Mm-hmm.
But with git bisect, which I haven't used much, and everyone talks about how it's such a cool tool of Git, but what it allows you to do is apply a command to two different points in time in Git history. And so you can, you could run your, let's say when I make that commit with the test, the failing test, I should be able to run it, or when I make my commit that has both the test and the fix, I should be able to run those two tests. Like the system could run the test against the broken version and against the fixed version and report yay, you fixed the bug. But
yeah, well, I feel like Git itself would probably need to be changed because the level, there's getting people on board with that might be hard. And I think one of our listeners actually put in the question, why is testing like a second-class citizen or an afterthought or whatever? So we're already struggling with that. And then to say, oh, here, let's do this git bisect thing. I think it needs to be more mainstream. I mean, all of that, if it's important, it needs to be in the mainstream, because if it's not, people will just default to whether the compiler allows their code to compile or not.
Right. Yeah.
It's not, we haven't evolved to the point where the bubble outside of the compiler is part of the whole, development process.
Yeah.
There's a lot of people that just go back to, well, I'll just, the compiler is the final arbiter of everything. And so if they
have a compiler, in the case of JavaScript, it's like, well, I pulled up the web page in my browser and it loaded and did what I thought it would. So
right, exactly.
I'm good.
Yeah. And even though there are linting tools and things, that's, the linting tool doesn't prevent you from deploying the code. If JavaScript doesn't work right, or your compiler refuses it, and actually prevents you from deploying the code.
Yeah.
So we're not,
That's a good point, is you have to run the compiler to get to an artifact that you can then run in compiled languages. Right. But in linted, if all you have is a linter, there's no guarantees that you're actually going to run the linter before you create the artifact and deploy it.
Yeah, it's unfortunate, but I think it's a learning process. I mean, it was a learning process I went through.
Yeah.
Thinking that, oh, well, the compiler passed it, it must be good.
There are times where I will make large changes, and I only validate with a compile. And this is because I have strongly relied on the type system to validate my program, which works in some cases and doesn't work in other cases, because there are definitely places where logic needs to be tested, and that can't be tested through types.
Sure. There's a boundary. I think this is the Gödel's incompleteness theorem, which basically says, any system with a boundary can't be completely tested, or can't be completely validated. There's always an outside. There's always something bigger that the system is a subset of. And so it's, like you go, oh, the type system is great. Sure, it is great, but there's things that you can't test with it. And it's like, well, and you look at Python and you go, well, especially before it had the optional static typing, you go, oh, well, it's further over here on this spectrum. And all you're doing when you add like a lot of good type system stuff is you're moving the bar, but your function takes an argument that needs to be within a certain boundary. You have to test that, your type system. Maybe some type systems would test that, but they might be going way overboard, and they might make your both expressiveness and productivity greatly reduced.
Yeah.
And you have to take those into account. So the book already has a nickname, because there are books that people refer to not by their title, but by their nickname. And so this will be the prep book.
Yes, the prep book.
Okay. You have big plans.
Interestingly, I have a project I'm working on, and the tests all usually work great locally. I think they always work great locally on my local machine. But in our CI environment, tests will just randomly fail. Like, I think a lot of people deal with flappy tests. And I'm like, I don't know what's different about the test environment that we're running in, but something is different. Maybe it doesn't have as many CPU cores. And so maybe there's like different thread contention. Maybe I have encountered bugs in concurrent systems where if you only have a single CPU, things get deadlocked. And so maybe that's part of it. But it's been interesting to have this Gödel's
incompleteness theorem. Yes. There's a book called Gödel, Escher, Bach.
Okay.
And it explains kind of a lot of the thinking and stuff. And
the environment changes, right? And that is a source of bugs and lack of reliability because
So what do you do when it works locally, but your continuous integration system says, we're having failures?
We added retries.
You added retries. Okay.
Yeah. Which is, I think, the typical but unfortunate way that we often deal with flappy tests. Flappy.
Is this
flappy?
Is this an acronym for something?
No, it just flaps like a flag in the wind.
Okay.
Sometimes passes, sometimes doesn't. Sometimes passes, sometimes doesn't. So flappy tests. So the typical way is you just add retries and you say, all right, try this thing 10 times and hopefully one of those 10 times is going to pass.
I don't know how I feel about that.
I know. It just feels like the wrong way for sure.
Yeah. I have to say, even on some of my simpler things, I've had, book examples, but some of those were concurrency examples. But, and it would work on the continuous integration system. And then I'd be, developing and doing things and put it up. And then it would give me this, I'd get an email sometime later that I would notice. I was like, something's not working. I'm going, but it's working on my local machine. Why is this happening? And it could very well just be you've got the free one, so you're only getting one processor. And so concurrency gets all bollocksed up. But
and you just had an issue on your Windows machine where something with your Java CA certs was screwed up and was making things fail in some weird ways. And
that was just that was something with the permissions. And so Gradle would try and go, and it wasn't a Gradle file, but you get the error messages in Gradle, and they would say things like, cannot access this site. Well, I know the site is out there. And it's very mysterious, and it's hit me a number of times over the years, and I finally figured out, it's the CA certs file, and they get out of sync for some reason, or you install a piece of software that's using Java. It may put it earlier in the path, and then your Java goes, no, that's not the right date. I don't trust anything about that. Not going to download anything. But the error message isn't, and it doesn't happen often enough, and it's hard to reproduce. That's the thing. It's an installation order issue, I guess. Anyway, that's one of the few wins I've had in the last few weeks. I have been stuck. So I think I've decided it's just the existential crisis that comes from finishing a book. You leave this neatly ordered book world where you know it's coming and you know what the problems are to solve and everything. And then it ends. Now it's like, oh, what do I do with myself now? Start another book, but doesn't always. I think it's inevitable. I think it's just something I have to work through.
I don't know what you did, but
I wrote the book.
That's right. Your penance for writing a book is to have to write another book.
I have to write another book, but also to have to go through the existential angst of the period between books when your brain has to disengage from one and engage to the other. So,
we were talking about testing. I was thinking about one of the evolutions in testing that I've seen that is pretty interesting, and you actually mentioned it, or mentioned the need for it. The problem that it's solving is property-based testing. Property-based testing is this approach where, let's say you have a function that takes an int, and usually when you manually write tests, you're going to write a test that sends a 1 and a 3 or whatever to this function, and you're going to test the output of those things. With property-based testing, instead you say, okay, I have a function that takes an int, and the test framework will actually just throw a bunch of ints at it and see and you have to tell it how to kind of compute the result with any given value, but it'll throw a max negative int, positive max int, zero, right? It'll just random. So it just does this. It doesn't do all the possible ints. It does some subset of those, and you can write generators.
And you can also, once something has been tested, it can put it. Well, it can put special values in a file to make sure that they get run, and then. I don't know. It gets very smart. It's
some pretty clever
generative testing. I know there's another name for it than just property-based testing. I first saw it in Python. I don't think it necessarily originated there, but it got a lot of use in there. And so it just
strings are an interesting one where there's so many things that your code can get messed up on with strings, whether it's UTF-8 encoding or whether it's weird values, empty strings, whatever, huge long strings. And so this is one place where I think reliability has been able to take another step forward on the process side is by doing more complete testing rather than just the manual, here's the values that I have manually encoded.
Yeah. And there's certainly, most websites you go on, you go, boy, this could sure have used. They didn't think about this obvious case, which I happen to have to type in, and then it gives me, and it doesn't do the right thing.
Yeah, that's form handling should definitely use property-based testing.
Yeah. So there are a fair number of. I think the fundamental idea of and I think those ideas came from the pragmatic programmer. They're the ones that said, you got to have version control, testing, and automated build before you can do anything. If you're not doing those, in fact, somebody was saying they could tell where an organization was by saying, okay, so how do you do these three things? And they go, if they say, oh, well, we don't do that for any of them. And it's, surprising how many maybe don't have version control or.
Well, you can probably correlate how well you do those things with how reliable your software is.
Yes. Well, I mean, because they're so fundamental. Yeah. They're like, without those, you can't really do anything else. You can't do the refactoring or code evolution or anything like that, because eventually it's going to bite you and you're going to get stuck. Yeah. So you kind of have to have those things before you can do anything else. And I think, well, this might have been when Barry was training, he'd go in and figure out where they were and say, oh, I see, you're not doing version control. So that's what we're going to work on. Yeah. Because it's pointless otherwise.
Right. Yeah. You got to get the foundation there so that you can build everything else.
Yeah. Move forward. And I think we're trying to look at it from, assume that's the case. Now we're going to look at actually how your code is constructed and how it works, which is the neglected part.
Yes. Prep.
Yes. The prep book. I know. Yeah. I'm glad you think it's funny.
It's hilarious.
Because you just made it up.
Just made it up.
Yeah, it was funny.
Words out of the air.
Because this article that you sent me that I started reading where they were saying, oh, actually, object-oriented programming was a hack in Simula so that they could get their garbage collector to work easily. And I started thinking along those lines, and I thought, well, yeah, because to make a garbage collector work easily, you want all the pieces to look the same. Yeah. How do you do that? Well, I guess if we said that there was this base type that everything was derived from, then the garbage collector would just work with pieces of the base type. Oh yeah, it'd be simple. And you could do reference counting on those things and all that. Okay, let's do that. And then I think we've been backfilling the ideas ever since then to go, look at this great shape example and the polymorphism and all that kind of stuff. And it may have all just come from somebody trying to hack
the lore of object-oriented programming, right? It's like, we thought that this was needed for some reason, which turns out to not be true.
Yeah. 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 It was just, we were just hacking to make the garbage collector easier. And I mean, it fits in my head when I think about it that way. Although I don't necessarily know how you would go to inheritance from that. I mean, I think Simula had inheritance. I never really studied it. Yeah. It's very weird because a big center of Simula was UC Irvine. Oh. And I remember I was studying physics and engineering and stuff, but I was taking a few computer courses. And I remember hearing about Simula. And of course, now I think, wow, I could have been in on the real ground floor back when I was there. But,
where OO was born.
Well, I don't know that it was born at Irvine. I think it was all over, but I just know that they did a lot of work with it at the time, and it was super early, and it was like, I think way over my head at the time. Yeah. So, but who knows?
Yeah.
Who knows?
Who knows? Well, that's fun.
Yep. We were experimenting with the boundaries of having less and less structure, because this one, both of us kind of went in going, nothing happened to me for the last time.
I didn't tweet anything interesting this week.
The pipeline is empty. Yeah. I may have talked about all of the things at this point because I'm not being productive.
Well, I have a book for you. It's called Prep.
Is it?
I'll get you your star.
Okay.
Yeah.
Well, that would feel productive if I achieved a star. I don't know if it would actually be productive.
Oh, it's just the NFT of a star. So,
yeah. Okay. I can put it on a t-shirt.
I don't know what you can do with NFTs. You could put it onto an NFT.
Yeah.
A t-shirt, an NFT of a t-shirt.
Sounds recursive. All right.
All right.
All right.
That was fun.